Hi guys, welcome back to Lessons in Geometry with Miss B. So we're going to be going over lesson 15.3, tangents and circumscribed angles today. So we're going to go over some vocabulary first. Okay, these are important terms to know because they're going to be talking about them in the problems, and if you don't know what they mean, it'll be a little hard to understand what your problem is trying to ask you. So a tangent is a line that is in the same plane as a circle that intersects the circle in exactly one point. The most important thing here to note is that this intersects exactly one point. Okay, so here, I'm going to pick my pink again. This right here is my line of tangency. So this is my tangent. Okay, the point of tangency is the point where a tangent and a circle intersect. So that's right here. Okay, that's exactly where they hit. So that's the point of tangency. The tangent radius theorem states that if a line is tangent to a circle, then it is perpendicular to a radius drawn to the point of tangency. So this is just saying that the angle where the point of tangency hits the circle, okay, is 90 degrees. That's all this is saying. So if you can remember that wherever the tangent is and where it hits the circle, that's 90 degrees. This is going to be really important to be able to solve some of your problems. The converse of the tangent radius theorem is a very long and confusing definition. So I wrote out the textbook definition, but basically what this is saying that if you have a tangent and you see that it's hitting the circle, then you know that it's perpendicular, okay? So this perpendicular line, if you see a perpendicular line, then you know it's a tangent, okay? That's all this is saying. The circumscribed angle theorem is a circumscribed angle of a circle and its associated central angle are supplementary. Okay, so remember that supplementary equals 180 degrees. All right, so here we have the vertexes outside the circle. So that's the vertex here is x. And I've drawn that the light blue angle, which is our circumscribed angle, and our light green angle, which is our central angle, are equal to 180 degrees. Now, there's something else really important that you need to know about this. So here in pink, I'm going to draw that this line right here, so line XA and line XB are congruent to each other. Remember that congruent means equal. Okay? So I also have line AC and line BC are equal to each other. Now, you'll see that line XA and XB have one dash, and line AC and line CB have two dashes. This just means that they are not congruent, so line XA is not congruent to line AC, but line AC is congruent to line BC, okay? So that's really important. So AC and BC are our radii. So our radii are always equal to each other. So we're going to be using these properties to solve some examples. So for our first example, they want us to find angle Q. So I can say that angle Q is my central angle, and angle P right here is my circumscribed angle. Okay? And since we just learned in the tangent radius theorem, and the converse of the tangent radius theorem and the circumscribed angle theorem, okay, we can say that the central angle and the circumscribed angle are equal to 180 degrees. So I'm going to say 180 plus 42 is, 180 minus 142, not plus, gives me a total of 138 degrees. So I can say that angle Q equals 138 degrees. Okay? So that's one of the more basic examples that you're going to see. So we can also use the property of the circumscribed angle theorem to solve for x and solve for our angles. Okay? So I want you to pause this video and I want you to see if you can make an equation that will be able to help us solve for angle P and angle Q. Okay, so hopefully you went and you solved for the x, or you set up an equation. So I'm going to set up the equation for you guys, and you can see if you got it right. So I'm going to say that x plus 3x equals 180 degrees. So I'm going to combine like terms, which gives me 4x equals 180. Divide by 4 on both sides. And x is equal to 245 degrees. Okay. So I go up here to my angle P. Angle P is x equals 45 degrees. So I can say that angle P is equal to 45 degrees. Okay. And my angle Q is 3x equals 3 times 45, because I just plug in my 45 for x, which gives me a total of 135 degrees. So I'm going to say angle Q is equal to 135 degrees. And that's my answer for this example. So here is where we're going to use our congruency properties that I went over up at the top. Okay, so this is going to be really important. Now, this is one of our more difficult examples. So if you struggle with this, please feel free to reach out to me through Google Voice or through the Remind app or through email, okay? And we can go over them. I'm also going to be posting a video of the worksheet, and we're going to be going over how to solve for problems like these. So they want me to find angle BOA, which is right here, and angle not angle OBA. That was the wrong thing. And angle OBS, okay? So OBS. Okay? So I'm going to start by solving for angle BOA, all right? So BOA is my central angle, and angle P is my circumscribed angle. So using the circumscribed angle theorem, I'm going to set 180 degrees minus 48 degrees to find angle BOA. So 180 minus 48 degrees gives me 132 degrees. So that's angle equals angle P. All right, so now we're going to use the fact that angle BOA, or that, BOA and BOA and S form a triangle, okay? So we're going to pull this out and say that this is a triangle. So I've got S, B, and A, okay? And I'm going to say that since not SBA. It's OBA. Okay? So I'm going to use the fact that O is equal to 132 degrees. And I can say that since these are congruent, that means that my base angles, so this angle and this angle, are equal to each other. Okay, so that means I can do 180 degrees minus 132 degrees gives me a total of 48 degrees. Since I have both angles are equal to each other, I divide by 2. So that gives me a total of 24 degrees. Okay, so I can say the angle OBS is equal to 24 degrees. This is not angle P, this is angle BOA. Okay, I was stuck on what we were doing in the last problem, apparently. All right, so this is how you find this, okay? So if you have any questions, please don't hesitate to reach out to me. I'm going to be posting a comprehension check where I won't be doing as complicated as our last example. It'll be more like this example and this example, okay? So if you review this video, you should be fine. I'll talk to you guys soon.